Today our topic is linear dependence and linear independence of vectors. Suppose we are given the vectors a1, a2, an and the scalars small a1, small a2 up to small an, and we can multiply the vectors by the corresponding scalars and then add the corresponding scalar product to form a vector. Okay, so here the vector v is represent uh, the scalar product with the vectors. Okay, the sum of the scalar product with the respective vectors. So such a vector v is called a linear combination of the vectors a1, a2 up to an, right? So now let's see the main definition of a linear dependence or linear independent, right? So now the definition: the vectors a1, a2 up to an are linearly dependent if there exists scalar small a2 up to small an. We denotate the vectors by capital letters and scalars by small letters, right? So the scalars are not all zero, such that the the combination, the linear combination uh, of the vectors here, the represented here the a1, the scalar multiplication with the respective vector, which is equal to 0, right? The sum of the here notice here, so the sum of the scalar product of the respective vectors, which is equal to 0. So otherwise the vectors are linearly independent, right? So if the sum of the scalar multiplication scalar product with the vectors is equal to 0, then we can say that the vectors are the linearly dependent, and otherwise the vectors are the linearly independent, right? So the above definition may be restated as follows: that the consider the vectors equation like this. So here the x1 and here the x1, x2 and x dot xn is represented here are the represented the scalar, right? So those are not zero and unknown scalars, right? So and we multiply the scalar with the our respective vector, right? So x1 with a1 and x2 with a2 and sum together, which is equal to a zero vector, right? So where the x1, x2 dot xn are unknown scalar, and this equation always has zero solution. So when x1, x2 and up to xn, all the scalars become the zero. So if this is the only solution, then the vectors are the linearly independent. And if there is a solution with some scalar which is not equal to 0, then the vectors are linearly dependent.